Ever since I was a kid, I have dreamt of becoming a scientist. And back then, when I was still in preschool, there's this show called The
Wow.
Mythbusters, which left a big impact on me. At that time, I thought a scientist was someone who not only looks smart, but are actually capable of creating something crazy this world has yet to witness. Someone who possesses the powers to change the world, and basically playing God by challenging the nature of things. Time flies, and now I'm a university student majoring in biotechnology. One peaceful afternoon, I stumbled upon a science innovation competition while I was in class. As a fresh year student filled with zeal and enthusiasm, I quickly called upon my trustworthy teammates to sign up for this competition. Ladies and gentlemen, I'm Biotechy, and this is how it all began. Although I have a team now, we don't really have any clue on what we should do or where we should start. Considering all of us were amateurs, none of us have any experience in joining science competitions. So naturally, we decided to seek professional guidance and approach one of our professors. You see, Professor Sufyan is actually an expert in bioprocess and biomaterials, basically industrial biotechnology. So, my team and I decided to focus on the application of biopolymers for
Wow.
our science project. And after doing some research, we found out that humans have actually tried creating biodegradable plastics, such as using cornstarch, algae, seaweed, and polylactic acid, also known as PLA. PLA is commonly used as the filament for 3D printing if you have not known. And these materials might already sound pretty familiar to you, and some of you might have even tried replicating bioplastic recipe at home. With that in mind, our team wanted to create something unique, uncommon, and worthy for the podium. We are here to win, and in order for us to win, our project must stand out from the others. Eyes on the prize, and we decided to do more research on biodegradable polymers. Soon, we found a biopolymer that checks all boxes. It is environmentally friendly, it is biocompatible, meaning it's not toxic to humans, it shares similar mechanical properties as your daily use plastic, and most importantly, we have access to it. Allow me to introduce you to polyhydroxyalkanoates, PHA. So, here's a brief explanation of PHA if you don't know what it is. PHA is produced via fermentation as carbon reserves for certain microorganisms such as Putida when they are placed under limiting conditions such as excess carbon and limited nitrogen. To better understand what that really means, try visualizing this. Imagine you're feeling stressed and you're eating a ton of sugar and carbs every day, but you're not getting enough protein or vitamins. Your body starts to think, I might be in trouble, so better store this energy for later. So, it starts storing fat as an energy reserve just in case. And this is why you should eat your vegetable kids, otherwise you will grow fat. That explains what microorganisms do with PHA. They produce and store it as their fat or energy backup. Now that we have confirmed our biopolymer, we can proceed with the next step.
Psych!
I lied. It's not over yet. Did you really think it would be this easy? The answer is no. Well, you see, PHA is segmented into different categories, mainly short chain length and medium chain length PHAs. The biggest difference between these two PHAs in terms of properties is that MCL PHA, also known as medium chain length PHA, is softer, more flexible, and less brittle compared to its counterpart, the SCL PHA. Now, for you science nerds out there, SCL PHA monomer comprises of 3 to 5 carbon atoms, while MCL PHA monomer consists of 6 to 14 carbon atoms. So naturally, the longer the chain, the more points of rotation, allowing them to bend and twist more without breaking easily. With its favorable
Approved!
properties, MCL PHA is usually used in biomedical applications such as adhesive materials. Now that we have confirmed our biopolymer, which is MCL PHA, we just have to figure out the best way to create our masterpiece using MCL PHA. I'm not gonna lie, it took us 2 whole weeks before we could settle on a solid idea. Let me boil down our thought process. First, I wanted to capitalize on the fact that MCL PHA is biocompatible. So, I proposed that we make a MCL PHA glove, which in theory, it should make a lot of sense. The problem statement is that gloves are major pollutants to the environment and some people are allergic to latex gloves.
Wait a minute!
That would be a great idea if not of two problems. Problem 1. MCL PHA is costly. Production costs of PHAs can range from $4,000 to $1,500 per metric ton, which is approximately 4 to 10 times higher than petrochemical-based polymers. By the way, MCL PHA is generally more challenging to produce than SCL PHA due to more complex production pathways. Problem 2. We don't have enough MCL PHA. We don't have enough ingredients to produce a lot of MCL PHA. I will explain how my team produced MCL PHA later, but for now, just note that the production requires a lot of different ingredients and approximately 1 gram per liter of PHA is produced using 1 liter of cooking oil. Aside from that, we were also sharing the lab with our fellow final year students who were also trying to produce MCL PHA, making it more difficult to use the equipment in the lab as we have limited amount of everything. So with that in mind, we scrapped the idea of creating MCL PHA gloves because it requires more PHA than we could afford, and shifted our focus to something smaller yet significant. After doing some research, by research I mean with the help of our great assistant, Mr. ChatGPT, we came up with the idea of creating a new gum. The birth of our idea, MCL PHA gum. Now that we know what to create, we can surely proceed with the production, right? Hold your horses, young man. It ain't that easy. See, especially in the bioscience field, scientists all around the globe have great ideas but just couldn't execute them properly, mainly due to lack of funds. Same goes for our team. We are just undergrads in our 20s and we don't have provisions to work with. We don't have our own lab to work with. So guys, what do you do when you are broke and needed help? The answer is simple. You ask for help. My team and I pitched our MCL PHA gum idea to Prof. Sufyan in hopes of receiving his approval to borrow his lab and use the equipment there. Also to have Prof. supervision throughout the competition. Aside from that, we paid a visit to the University Students Affairs Department to plead for funding. Why, you may ask? We needed some monetary budget to register for the competition and to print physical materials such as posters or banners. So after grueling interview sessions that felt like hours of interrogation, we finally got the green light and were promised to be given a certain amount of money after the competition. Great news for the team, and we headed off to a great start. Bear in mind that I was a freshman at that time, and it was my first time seeing a professional laboratory equipped with high-end facilities that I've never seen before. My heart was already pounding out of joy as my wish had partially come true. That is, to experience working in a professional lab with other professionals. While I was still on cloud 9, my team was introduced to Dr. Siraj, who will play the role as our team supervisor alongside Prof. Sufyan. We explained our plan to both doctor and professor, and we officially commenced our first day at lab on a Monday. We had 2 months to prepare for this competition. Seems like a lot of time, isn't it? For the first month, we dedicated our time to trying to produce MCL PHA, which is needed to make gum base for chewing gum. And this was the time I realized how difficult it was to create 1 gram of MCL PHA. If you remember what I've said just now, MCL PHA is produced via fermentation. What that also means is that it takes up a lot of time just to wait for the microorganisms to undergo fermentation. Letting the flask shake on the shaking platform for days, well, it dawned on me. I realized that 8 weeks is just barely enough time for us to create our product. There wasn't a lot of reading time, to be honest. So let me do a quick rundown of the procedures of producing MCL PHA. First, prepare a nutrient broth, NB, to promote bacterial activation and growth. Then, incubate on reciprocal shaking platform for 24 hours. Next, prepare a nutrient-rich medium, NR, and pipette the nutrient broth containing bacteria into each NR flask. Then, incubate on reciprocal shaking platform for 24 hours. Afterwards, prepare a mineral medium, also known as E2 medium, which in my case, limits the nutrients but supplies excess carbon to the bacteria to divert resources into PHA synthesis instead of cell growth. Then, incubate on reciprocal shaking platform for 48 hours. After 3 to 4 days, it's finally time to harvest bacteria that have synthesized PHA. What we specifically do here is centrifuge, washing, and freeze drying. Now, what we have is basically a mixture of dead bacterial cells and PHA. Since we only need PHA, we need to filter out unneeded biomass. We dissolve PHA stored inside the bacterial cells using chloroform, filter undissolved cell debris, and evaporate the solution to leave behind crude PHA. We also wash and purify PHA using a rotary evaporator. From this experiment, take note that chloroform is used to dissolve and extract PHA while separating it from cell debris. Hope methanol is added after dissolving PHA in chloroform, and this is to precipitate the PHA out of the chloroform solution, allowing it to be separated by centrifugation. Lastly, you cast and dry the PHA to turn it into a film looking like bioplastic. Sounds fun, isn't it? Well, based on our experience, synthesizing PHA requires approximately 1 to 2 weeks. Given the limited time frame leading up to the competition, we had only a narrow window to successfully produce the PHA in time. Moreover, PHA itself is not the final product. You still needed to formulate it into gum prototype and carry out various performance tests. On our first try, we failed to synthesize PHA. When we tried purifying PHA using a rotary evaporator, for some reason nothing remained in the flask, which is bewildering. On our second try, we also failed to synthesize PHA. Supposedly when performing resuspension, we should be able to see strains of white substances, which indicates the presence of PHA. However, to our surprise, very little white strains appeared, and according to our supervisor, it was not the MCL PHA we are looking for. Perhaps it was PHA's cousin. Now, you could have guessed that my team and I were not doing great. We spent 4 weeks day and night working tirelessly, trying our best to give birth to MCL PHA. But the universe had other plans for us. It was a heartbreaking blow to swallow, and we started to panic and worry. What if we couldn't make it in time? Will all our efforts be in vain? How would we be able to face those who have supported us during our journey? Failure was not an option. We tried once again, and this time we finally got MCL PHA. But it's not done yet. With 2 weeks left, the boys and I once again spent days and nights formulating the prototype of the gum and carrying out performance tests. The gum making wasn't difficult nor time consuming. After several trials, we finally found the perfect recipe to create a somewhat ideal consistency and texture of the gum. Then, for the next few days, we did a degradation test using biomass weighing and gel permeation chromatography, also known as GPC. We also performed a dissolution test via spectrophotometry. Finally, my team is ready for the competition. But wait, there's something missing. That's right, just one day before the competition, I almost forgot about the science poster, so I spent the entire day getting it done and printed. Fast forward to the competition day, we were excited to explore the other team's booths, so we took the opportunity to look around. There were a lot of interesting projects, notably turning jackfruit rinds into 3D printing filaments, which piqued my interest the most. I'm so glad that I was able to be part of this competition and to meet a lot of great people. Everyone was kind and welcoming, and I've also learned a lot from the other contestants. In the end, we were placed 4th in the undergraduate category. Overall, the experience was great and it was a great stepping stone for future projects and competitions. I would like to thank my teammates, supervisors, and the university for giving me the chance to experience such a competition. See you next time, I guess. Bye!